This video is all about circles. Here we we learn the definitions, related parts, and the concepts. If you remember, your nursery teacher would have drawn something like this and would have told you this is a circle. Since then, you started recognizing this shape as a circle. Your drawing always showed sun or the moon as round in shape. This means from the childhood we knew circle as something which is round. Now let us define a circle. A circle is a set of points which are at a fixed distance from a fixed point. So they are set of points. How it looks? It's like this. So if you see here, these are all the points. These are all the points, and there is a set of points. They are following a certain rule, that is, it has a fixed point. The fixed point is called the center of the circle. This is called the center. This is the distance of the point from the center, and that is a fixed distance. The fixed distance is called the radius of the circle. Radius of the circle. So the fixed point is called the center of the circle, and the fixed distance is the radius of the circle. The set of points forming the circle or the boundary of the circle is called the circumference of the circle. So these are the set of points. Okay, these are the set of points, and these points forming the boundary is called the circumference. In a circle, we can draw infinite number of radius because every point could be connected to the center. So we will have infinite number of radius. So this is your circle. When you draw a circle, the plane of the paper or the slide gets divided into two parts, two regions. Okay. The region inside the circle is called the interior of the circle, and the region outside the circle is called the exterior of the circle. So here this is the interior and the outer part is the exterior. So let us write it. Interior of the circle, and this is the exterior of the circle. Chord of a circle. This is a circle. This is a chord. Chord. Okay. So how do you define chord? A line segment with its end points on the circumference of the circle is called the chord of the circle. Okay, this is the end point of this line segment and it is on the circumference of the circle. Therefore, we call this as the chord of the circle. It's a line segment. In a given circle, infinite number of chords can be drawn. Now let us see how it is. So this is a circle. We draw, see the number of chords we can draw. We can draw infinite number of chords. So if you closely pack these chords, so you will have infinite number. So we observe that as we start from one end of the circle and move towards the center of the circle, the length of the chord increases. So this is one end of the circle. See this length, see this length, this. So as you go towards the center, the length of the chord increases. And if you start moving away from the center, the length of the chord starts decreasing. Clear? So we can draw infinite number of chords and the length of the chords increases or decreases. If you go from the out from one end of the circle towards the center, the chord length increases, and from the center, if you go to the other end of the circle, its length decreases. A chord which passes through the center is the longest chord and it is called the diameter of the circle. So we have a number of chords, but among all those, the one which passes through the center will be the longest chord. And that longest chord is called the diameter of the circle. So you can say that diameter is the longest chord. So diameter is the longest chord. It's also a diameter is also a chord. Now next see. The circle. This is the diameter. Center. This is a radius. This is also a radius. So what you get? Radius plus radius is the diameter. So diameter is r plus r, that is 2r. So diameter is twice the radius. Twice the radius. In a circle, infinite number of radius and infinite number of diameters can be drawn. So infinite number of radius and infinite number. So you can connect across this, passing through this point center, you can have infinite number of diameters also. So diameter is twice the radius. This is the formula. Now look at the circle. So this is the diameter. So this diameter, once you draw this diameter, the circle gets divided into two parts. Each part is half of the circle and that is why it is called the semicircle. So the diameter divides the circle into two semicircles. Diameter divides the circle into two equal halves. Each half is called a semicircle. So this is how a semicircle will look. Only if you take out a semicircle, this is how a semicircle looks. So semicircle means you can say half of a circle is called a semicircle. Arc of a circle. This is a circle. This portion of the arc, a part of this circle, part of the circumference of the circle is called the arc of the circle. From here to here, this red part is called the arc of the circle. PQ, so we can say PQ is the arc of the circle. A minor arc is a smaller part of the circle PQ. So this is a smaller part of the entire circle. So it is called as a minor arc. If this is minor, the remaining bigger portion is called as a major. So the major arc is the larger part. That is PRQ. That is P. You'll have one point here. This is a major arc and this is R. So P, R, Q is the major arc and the smaller portion is the minor arc. Now see the circle. Now what are you learning? You got a minor arc. Okay. This is the center of the circle. PQ is called the length of the minor arc. If you take a thread and lay it along the arc, straighten it and measure the length, it is the length of the arc. So if you take this portion, if you take it and measure it, this is called as the length of the arc. Now let us join these 2 points P and Q to the center of the circle. When you join it to the center, you get an angle here. Angle made by the arc at the center of the circle is called the central angle, denoted by theta, that is angle POQ. So this angle POQ is the central angle which is formed by joining the endpoints of the arc to the center. And the angle is formed at the center, therefore it is called the central angle. Okay, minor arc, major arc. So if this is the central angle, if PQ is the arc, minor arc, if you join it, you get a central angle. Suppose you join the major arc to the center, that is, this is PRQ is a major arc. So if you join it to the center, you get what is called as a reflex angle POQ. And reflex angle is 360 minus theta, because the complete angle is 360 degrees. Therefore, subtract the minor angle, you get the reflex angle, that is the central angle for the major arc. As the arc length increases, the degree measure of the central angle increases. So if the length of the arc, that means instead of PQ, if it were up to this length, the central angle will also be bigger. Further it goes, further it will be larger. So when the length of the arc becomes equal to semicircle, then the central angle is equal to 180 degrees, which is the diameter. Now you have a circle. This is a chord. Segment. Now segment of a circle. The region between a chord and its corresponding arc. This is a chord. This is the corresponding arc. This region is called the segment of the circle. Okay. Minor arc lies above the minor arc up to the chord. Minor segment. Because smaller portion, it is called as a minor segment. Above this arc and up to the chord, this region is called as a minor segment. See how it is? This part. See, this part is called as a minor segment. Minor segment. Clear? If this is minor, the smaller portion, then the remaining bigger part should be the major segment. Major segment lies above the minor arc. Sorry, below the major arc up to the chord. Below this is a major arc. Below the major arc and up to the chord, this is called as a major segment. Major segment. So the chord divides circle into minor segment and major segment. The major and minor segments of a circle are called the alternate segments of each other. Alternate segments of each other. Sector. The region enclosed by two radii and the arc between them is called the sector of the circle. This is the circle, two radii. This is one radius, this is the second radius, and the arc between them. This is the arc between them. This region, this portion is called the sector. Okay. So minor sector corresponds to the minor arc and the two radii. This is a minor arc, as we have already learned what is a minor arc. So this is a smaller portion of the arc. Therefore, it is a minor arc, and you join it with the radius to the center. Then we get as a minor sector. Now, so this is a minor sector. If minor is there should be a major also. So major sector corresponds to the major arc and the two radii. This is a major arc. Okay. This is a major arc and the two radii. This is the major sector. Major sector. Now, radius, another radius. This is the minor sector. You have just learned. So now let us see what I'm going to do. Central angle. Angle made by the two radii at the center of the circle in a minor sector is called the central angle, denoted by theta. That is angle AOB. Minor theta. This is the central angle. This is theta. O is the center of the circle. So central angle. Got an idea? Reflex angle. 360 minus theta. This is 360, complete circle, minus this theta is the central angle. So this is a major sector, and this is the center reflex angle. This part from here to here is a reflex angle. So complete angle is 360 minus this theta is a reflex angle. Reflex angle. Clear? Hope I'm clear, and I'm quite going slowly so that you really understand what the concept is. Okay, these are the various concepts which you are learning. Now, central angle, you can also define that as degree measure of the minor arc at the center of the circle containing the arc is the central angle. So you are defining it. So different times you will get different. Before this also I have defined the central angle. Now again I am using two more definitions to say that, to tell you that it could be defined in different ways, considering the angle, considering the arc, and etc. Okay, angle made at the center of the circle is called the central angle. So degree measure of the minor arc at the center of the circle containing the arc is the central angle. So the central angle concept is clear. Now, reflex angle, degree measure of the major arc. Degree measure of the major arc is 360 minus theta, that is 360 minus angle AOB. This should not have been much. Okay. Now, inscribed angle. An angle made in the interior of the circle, that is inside the circle, by two chords intersecting at a point on the circumference of the circle. Now let us see the figure. You will get a clear idea. This is a circle. You have one chord. This is a chord, isn't it? A AC is a chord. We draw another chord. BC is another chord. Okay. So this is one chord, another chord, and inside in the interior of the circle, intersecting at a point on the circumference of the circle, that is point C. This angle is called as the inscribed angle. This is angle, so it is denoted by theta, and this is the inscribed angle. Hope I am clear. A circle can have infinite number of inscribed angles. I have drawn here. I can draw it like this. I can draw it like this. I can draw here one more nearby, or you can have one more like this. So you can have infinite number of inscribed angles. Okay, starting from the same arc AB. Relation between central angle and the inscribed angle. Now you know an arc is there. You can make a central angle, join the endpoints of this arc to the center. You get a central angle. So what is the relation between this two, central angle and the inscribed angle? We draw a radius joining to the point AB, that is our minor arc, and you get an angle which is the minor sector. And the angle here is, this is the major sector, and this should be twice the inscribed angle. The central angle will be double the inscribed angle. That is the relation between the inscribed angle and the center angle. What is the condition? Both of these angles must originate from the endpoints of the arc, same arc. AB is the arc. From this, we join it to the center, that is points A and B are joined to the center, and points AB are joined to a point on the circumference of the circle. If this condition is met, then the central angle will be double the inscribed angle. So if AB is a minor arc, angle AOB is the central angle, and angle ACB is the inscribed angle. Then central angle is twice the inscribed angle. Clear? So central angle is twice the inscribed angle, that is 2 into inscribed angle. Circle. So the relation between a line and a circle. You just draw a line outside the circle. This is a line, isn't it? So this is a circle, and you have drawn a line outside the circle, and this is the line. A line drawn outside or in the exterior of the circle is only a line. It is not related to the circle. It's a line, and this is a line. This is a line, and this is a circle. It's no way connected with it, so it is not related with each other. Now you see this line. It's cutting through the circle. So what is called? Secant. A line passing through the center, so passing through the circle or cutting the circle at 2 points is a secant. A line passing through the circle, cutting the circle at 2 points is called the secant of the circle. So see how many secants you can draw. All are cutting through the circle and all are intersecting at 2 points. So this, you can have infinite number of secants. Through a circle, infinite number of secants can be drawn as shown in the figure. So all these are secants. Clear? Now, tangent. A line which touches the circle at only one point is called a tangent. So suppose you bring this line further down, you will get one line like here. It is just touching the circle and passing. Now this line which is touching the circle is called a tangent. Okay, it is touching the circle. So the point where the line touches the circle is called the point of contact. It is a point where it is touching, so it is a contact point. So this is the point of contact. The radius of a circle is perpendicular to the tangent through the point of contact. Suppose if you draw a radius through this point, it will always be perpendicular. Infinite number of tangents can be drawn to a given circle. So you have got a tangent which you have drawn from this one point of contact. I can take this point of contact and draw one more tangent like this. I can take this point, again draw. I can take the next point, again draw. I can take this point, I can draw one tangent like this. I can draw one tangent here. I can one draw tangent here. So infinite number of tangents can be drawn. But through a given point of contact, only one tangent can be drawn. But through this point, if I ask you how many tangents can be drawn, this is the only tangent can be drawn. Any other thing which passes, it will go become a secant. So only one tangent through can be drawn through a given point of contact. Equal chords are equidistant from the center of the circle. This is a circle. This is a chord. This is another chord. Both the length of both these chords are equal. So this is the center of the circle. Let's draw. This is the distance of the chord from the center. And this is the distance of this second chord from the center. Because the chords are of the same length, their distance from the center will also be equal. That means these two lengths will be equal. Equal chords obtain equal angles at the center of the circle. Again, see the figure. Chords are equal. Length of the chords are equal means their length is same. Okay. Now let's make central angles. This is the center of the circle. We'll join the endpoints of the chord to the center. Join endpoints of this chord again to the center. These are the two central angles. Okay. And this angles will be equal. Both will be theta. So central angles made by equal chords will be equal. Angle in a semicircle is always 90 degrees. Circle, let's draw a diameter. So this is the center of the circle. Let's draw the diameter. So this is a semicircle. So in this semicircle, let us draw an angle. This is an angle. So this angle will be 90 degrees. Inscribed angle in the same segment are always equal because the central angles is the same. There is a circle, is a chord, inscribed angle. You can draw one more inscribed angle. You can draw one more inscribed angle. All these inscribed angles have the same degree measure, are equal. That means you say that they are equal. They have means equal means because they are angles, their degrees will be same. Why it is same? Because each of them have the same central angle. And you know, central angle is double the inscribed angle starting from the same end points. So the central angle is same. Therefore, all the inscribed angles originating from the same endpoints of the chord will be equal. Perpendicular from the center of the circle to the chord bisects the chord. The line joining the midpoints of the chord to the center of the circle is perpendicular to the chord. Same thing, but it's told in a different way. See, and to show you, this is a circle, this is a chord, this is the center of the circle. Let's draw a perpendicular from this. This is a perpendicular. Okay, 90. That means perpendicular means 90 degrees. You draw a perpendicular from the center to the chord. It will bisect the chord. That means it will divide into two equal halves. Okay. You can also say the other way. If you take the center of the chord and join it to the center, so if you take the midpoint of the chord and join it to the center of the circle, then this line will be perpendicular to this chord. Okay, you can draw a perpendicular and say it divides it into two equal halves, or take the midpoint of this chord and join it to the center, it will be perpendicular. Both ways. That's why two statements are written at the same time. Any angle subtended by the minor arc in the alternate segment is acute, and any angle subtended by the major arc in the alternate segment is obtuse. So alternate segment, acute angle, obtuse angle. So let us see how this is. This is your circle. This is your minor arc. Okay. If this is a minor arc, this is a minor arc, this will be the alternate segment. Okay. And from this endpoints, if you make an inscribed angle, this is a minor arc, you draw an inscribed angle. This angle is an acute angle. It's in the opposite or alternate segment. So this is your alternate segment, and the acute angle in the alternate segment is a minor arc. Now if you take the major arc, this will be the minor, this will be the alternate segment. When you draw here major arc, we draw an angle here in the alternate segment. This will be the alternate segment. So this angle is the angle which is formed in the alternate segment of the major arc. And this angle will be an obtuse angle in the alternate segment of major arc. Clear? With the figure, it should be clear. Next. Length of a tangent. The length of the tangent of length of the segment of the tangent between a point on the tangent and a point of contact with the circle is called the length of the tangent from the point to the circle. Now let us see exactly how it looks. This is a circle. Let's draw a tangent. Now this is the point where it's touching. It is the point of contact. And this is a point somewhere on the tangent. Say that's point P. So this distance from P to Q is called as the tangent length. This part, tangent length. Clear? So that is the length of the tangent. The length of two tangents drawn from an external point to a circle are equal. Circle, take a point outside the circle. Let's take P. From this point, let us draw two tangents. One here, another here. Let's name this point Q. Let this as R. So this is the tangent length from the external point on this tangent, and this is the tangent length from an external point on this tangent. So these two tangent lengths will be equal. Cyclic quadrilateral. A quadrilateral is called cyclic if its all vertices lie on the circle. That means the vertices means the corners of the quadrilateral is on the circle, then it is called as a cyclic quadrilateral. This is a circle. We draw a quadrilateral. So these are the corners of the circle. These are quadrilateral and they are on the circumference of the circle. Therefore, this quadrilateral is called as a cyclic quadrilateral. So you can name it as ABCD. When you name it as ABCD, there is a special property for the cyclic quadrilateral, and that is sum of the opposite angles of a cyclic quadrilateral is 180 degrees. That means angle A plus angle C. Opposite angles, angle A and angle C. Total of these 2 degrees will be 180 degrees. Angle B and angle D, total of these 2 degrees will also be 180 degrees. If one side of the cyclic quadrilateral is produced, suppose I produce this here, then the exterior one angle will be formed outside the, and this outside angle will be equal to the opposite interior angle. See this. So I have extended this side, you get an angle outside it. So this is an exterior angle. Okay. This angle will be equal to opposite interior angle, that is this. So this angle will be equal to this. So depending upon, suppose I extend it here, then this angle will be equal to this. I extend it here, this will be equal to this. So it will be an external, this one side only I have extended. You can do it with the other sides also. You will get a similar alternate angles which are equal. Now, if two equal chords of a circle intersect within the circle, okay, let us take a circle. Two equal chords. This is a chord AB. We draw one more chord CD. These two chords are equal in length. The segment of the chords are equal to the corresponding segments of the other chord. So this is one segment. So if you join the point of contact, this is the center of the circle and this is the point of contact or point of intersection. The segment, that is AP and CP, that means this segment is equal to this segment and BP is equal to DP. So that's why the segment of the chords are equal to the corresponding segments of the other chord. The line joining the point of intersection to the center. This is the point of intersection. If you draw a line joining the center, this line, okay, let's draw a little more further. L perpendicular here, and this angle will be equal to this angle, that is OPL. OPL, this angle, and OPM, these two angles will be equal. Chords are equal and the angle made by the chords with the line joining the center will be equal. If two tangents are drawn to a circle from an external point, then they subtend equal angles at the center. Again, tangents from the external point. Point A is a point outside the circle, so it's an external point. From this, I'm going to draw two tangents. AP, another one, AQ. And this will be the center of the circle. I join the center to the point of contact. I join the center to the external point and I join it to the points of contact also. When you join it, this is the angle subtended by at the center. This is angle subtended at the center and both these will be equal. AOP will be equal to AOQ. and they are equally inclined to the line joining the center. That means these angles will also be equal. Clear? So thank you for watching the thing. I think you understood it. You liked it. Then subscribe for this channel and share it with your friends and click the bell icon.